In this lesson, you are exploring overlap in data sets, and this is a brand new topic for all students in Accelerated Math 7 this year, I believe. I could be wrong. Maybe some of you studied it, but most people have not. So, let's talk about what mean absolute deviation is. Here it says it describes how far the data values are spread out from the mean. So that's the important thing to take away. The mean absolute deviation describes how far the data values are spread out from the mean. So the bigger the MAD, the more spread out the data is from the mean. And the smaller the MAD, the closer all the data points are to that mean. So let's talk about how to find the mean absolute deviation. The first step is to find the mean, and we all know how to do that. Add up all the values and divide by however many values we have. Now the second step is described right here. What you need to do is find the deviations. Deviation is how different it is than the mean. So in this example, the mean is 10. You can see that 11 is 1 above the mean. So that's where these plus 1s come into play. That corresponds to these points here. It was 1 above the mean. The 13 is 3 above the mean, and we had those 2 points right here. So that's where we're getting those values. If you take a look at the negative 1, that was 1 below the mean with that 9 there. These both are 2 below the mean, and those correspond to the 8s. And this one is 3 below the mean, which corresponds to the 7 up there. So this, what I have circled, are all the deviations. And then the step 3 is to find the absolute deviation. Absolute value is what we're talking about. So it takes all of these negative values that were below the mean and makes them positive. So the absolute deviations just turn all of those negatives into positives. So step 4 is to find the mean or average of all of these deviations. So to find the average of the deviations, we add them all up, all the deviations, add them all up, and divide by however many there were. So now it's time to find the average of the absolute deviations. So add the absolute deviations. So I'm going to add 3 2 2s, a 1, a 0, 2 1s, and 2 3s. So we're going to add up all of those numbers there. When you add up all of those numbers, you should get 16. So once you get the sum, to find the mean, you have to divide by however many numbers there were. So we added them up. Now to find the mean absolute deviation, we take the sum or total divided by however many numbers there were. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So divide by 9. And we get 1.7 repeating. Notice down here, they say the mean absolute deviation is 1.8 because they rounded 1.7 repeating. So I'm going to break down the term mean absolute deviation. So mean is average. Absolute means the positive values. positive. And deviation is how different it is. And in this case, how different it is from the mean. So we find out how different it is from the mean. We kind of work our way backwards. How different everything is from the mean. Then you take the absolute value of all of those numbers, and then you find the average of all of those numbers. And that's how you find the mean absolute deviation. Let's take a look at the next page. We are asked to calculate the mean absolute deviation for the heights of second graders, and the mean is about 50 inches. So they take that first step of finding the average, or the mean, away from us, so that's a nice thing. But normally, we would have to find the average on our own. So right here is the mean. So our second step is to find the deviations. So I'm going to say that these are 1 away from the mean in a negative direction. These are 1 away in a positive direction. From the mean, these are 2 away in the negative, and these are 2 away in the positive. This one is 3 away in the negative direction. These are 3 away in the positive direction. This is 4 away in the positive direction. This one is 7 away in the positive direction. And over here, this one is 7 away in the negative direction. So what I just did is I found all the deviations, and now I'm going to find the absolute deviations, which means I take all of these negatives here and make them positives. So absolute deviations. Let's see how many there are. So it's time to add them all up. So I'm working on finding the sum of the absolute deviations. So I'm going to have 1, 7, which I got right here. I'm going to have 1, 3. I'm going to have 3 2s. And I have 5 1s. I have 4 zeros. I have, now I'm over here on this side, I have 4 1s. I have 3 2s. I have 2 3s. I have 1 4. And I have 1 7. That 7 is this one here. Okay, so I color-coded it so you could see where I was each time. So now it's time to find the sum. You add up all of those things, and I would recommend just typing that into a calculator. So the sum of the absolute deviations ends up to be 48. So once we find the sum, we find the mean absolute deviation by taking the sum, 48, divided by however many data points there were. So you count up the number of dots that there were. There were 25 of them. So 48 divided by 25 gives us 1.92. So the mean absolute deviation is 1.92. That is a number that describes how far away the numbers are from the mean on average. So this next question is asking, how could it be that second graders' heights and seventh graders' heights have the same mean absolute deviation? So what you have to keep in mind is that we are not talking about the average heights of the students. We are talking about how spread out the heights are from the mean. So if you take your pencil and you kind of outline the shape of this dot plot, it looks like that. If you do the same thing over here, it looks very, very, very similar. So when the shape of the dot plots look similar, it means the distribution of data is evenly spread out. So how could it be that the mean absolute deviations are the same? Even though 7th graders are much taller, the spread of heights in 7th grade students is about the same as the spread of the heights of the 2nd graders. So again, even though 7th graders are much taller than 2nd graders, and we can see that by the middle numbers here, so if you take a look at those numbers, they're much taller in 7th grade, but the spread of the heights, which is what the mean absolute deviation talks about, is about the same. Alright, moving on to the next page. We have a red curve that has a mean of 300 and a mean absolute deviation of 25. And we are asked to sketch a second data distribution that is 4 mean absolute deviations away from the mean of the red curve. So we're going to take 4 mean absolute deviations. So 4 times 25 is 100. The words away from, does not distinguish if it's above or below. So we have 2 different possibilities. So if it's 100 away from the mean of the red curve, I will do 100 above in green. So I'm going to take this whole thing and slide it 100 units away. So I'm going to take that peak there and slide it over 100 units. So that would be about right there. And then I'm just going to copy what that shape looks like. So I'm going to take this point here, which is at about 150, and slide it over to 250. I'm going to take this dip here at about 250, slide it over to 350. Take this dip, slide it over to 450-ish, and take the bottom lowest part here and slide it over to 550. So I'm just sliding everything over so it looks something. This is just a rough sketch, and that's all I need from you. That's what it would be if it's 4 mean absolute deviations above the mean. Now, we could have also been below the mean. So what that one would look like, I'll do that one in orange, you would slide it the other direction. So you would take this point here at 150, slide it 100 lower, so that would be about 50. The mean was 300, it would become 200, and this point here at 450 would have come over to this 350. So all I'm doing is sliding that red curve over and copying what it might look like. Okay, I kind of messed that up. Let me try to fix that here. So it peaks there, and then it ends right there. So just do your best. I'm not looking for precision, just the idea that you understand it slides 100 left or right. Alright, for the got it, the red curve has a mean of 6 and a mean absolute deviation of 0.5. Sketch a second data distribution that is 8 mean absolute deviations away from the red curve. So we're going to do 8 times 0.5. So that's 4 away. That could be 4 above, or it could be 4 below. So if we do above in green, I will slide this whole picture 4 units to the right. So it did start at 3. If I move it 5 or 4 spaces, then it would start at 7. So it starts about right there, and then I kind of just do my best to copy that. So it's just above 8 at the end here, so it's just above 12 when I slide it over 4 spaces. Okay. If I'm below the mean, then I would go to the left. So I would slide everything 4 to the left. So if it started at 3, I'm going to start at 4 below that, so I'm going to be in the negatives here. And I do my best to copy that. So it did end just above 8, so now it's going to end just about above 4 when I slide everything over. Again, I'm not expecting perfection, just the idea that you understand it. Alright, the got it's, oops, sorry about that. The close-in checks are pretty extensive, so it's going to take you a while to do them. I want you to do 1, 2, and I'm going to give you the answer to 3 right now, but I want you to put it in Google Docs anyway, and then I need you to do 4. So for number 3, it's kind of hard to put this in words, so I'm going to tell you what you should write. Explain what the mean absolute deviation represents. Okay, so what you're going to write is that your answer means that on average, the flight delays differ by about, and then whatever your answer is, minutes from the average flight delay of 55 minutes. So it tells us how much it differs on average from the average. Lots of averages there. Hopefully that helps you understand that a little bit better. Now I need you to do 1, 2, fill in 3, and do 4 on your own, and then put them into the Google form that I created. Alright, so here's the bit.ly for 16.5. Make sure you answer the questions on paper and then put it into the Google form.